In our next section here, we're going to look at an example topology that I have set up with 3 different IGPs, where router 4 is running RIP, OSPF, and EIGRP, and we want to get reachability from the EIGRP domain to both the OSPF and RIP domains, and from the OSPF domain to the RIP domain. So first we'll look at what happens under the normal case of redistribution, what we should expect to see in the RIP database versus the OSPF database and the EIGRP topology when router 4 does the redistribution, and then some potential issues based on the normal advertisement rules of EIGRP versus OSPF versus RIP. So let's take a look at the topology on router 4 to start, and let's make sure that we are learning routes from RIP, EIGRP, and OSPF separately before we get into any redistribution. So on router 4, if we look at the show IP protocols, this is going to tell us what are the local routing processes that we're running and what are the local interfaces that have that particular protocol enabled. So we can see in this case that we are running EIGRP1 on interface that has this particular prefix assigned, okay, which in this case is router 4's connection to the frame relay network. Also says that we're learning updates from this particular neighbor, which is router 5 over the frame relay. The default administrative distance for that neighbor is 90, which is our default internal distance, and our default external distance is 170. So essentially the only thing that we have configured under the EIGRP process is just the network statement that is corresponding to that particular interface, and then the no auto summary. It says automatic summarization is not in effect. Likewise for the OSPF process, it tells us what particular links that we are running the protocol on. So whatever interface has this address 45.5 and the 146.4, these links are running in area 0. We're learning updates from 4 different neighbors, which implies that we have adjacencies with these devices. It says the administrative distance for all of them is 110. So we'll see that when we do modifications of the distance, we can either do this globally to the process, we can do it on a per neighbor basis, or we can do it on a per neighbor per prefix basis. But by default, the global administrative distance default value is going to apply for all routes learned from all neighbors. Then lastly, under the RIP process, it says that we're running RIP on this particular interface 204.12.28.0, and we're learning updates from this neighbor on the link using the distance of 120. So if we look at the end result of this and look at the show IP route, we should see that we have routes installed from OSPF, we have routes installed from EIGRP, and from RIP. We don't have any external prefixes yet because we just have the internal OSPF routes, we have the internal EIGRP routes. Then again, for a RIP, we have no way to distinguish the internal prefixes versus the external ones. Now, before router 4 even got to this point, where it was installing the RIP routes in the routing table or the OSPF or EIGRP, each of the individual protocols is going to go through its normal path selection process. In the case of RIP, we can see this by looking at the show IP RIP database. It should show any prefixes that we're learning, and based on this, we can figure out which ones are actually going to get installed in the routing table. So we have 8 separate prefixes that are being learned on our Fast Ethernet 0/0 interface, which is the 30.0.0/16, the 30.1, 30.2, etc. Also, it says we have a directly connected interface, Fast Ethernet 0/0, that is running the process. This would then imply if I were to redistribute from RIP into OSPF or from RIP into EIGRP, there should be 9 prefixes that will be included. The 8 that show up in the routing table as RIP, when we look at the show IP route RIP, so the 8 subnets we're learning there, plus the directly connected interface that is running the protocol. We'll see that this is going to be our implicit directly connected redistribution. The only case where this directly connected link would not be redistributed is if we were to manually issue the redistribute connected command under the OSPF process or under the EIGRP process, and then exclude interface fast Ethernet 0/0. So the explicit redistribute connected command, this is going to override any of the dynamic interfaces or the interfaces that are running the dynamic protocols. Then likewise for EIGRP, if we were to look at the show IP EIGRP topology, this is showing us the routes that should be installed in the routing table that have valid feasible distance values. So these are the dynamic routes that are coming from our different neighbors, in this case router 5. And then we also have our connected link that is running the process, 155.28.0.0/24. So again, just like RIP, the end result of this would be that if I were to redistribute EIGRP into OSPF, any routes that are in the routing table as EIGRP, so if we show IP route EIGRP, plus the routes that are in the topology as connected interfaces, those are the ones that are candidate for the redistribution process. Then likewise for OSPF, if we show IP route OSPF and show IP OSPF interface brief, the dynamically learned OSPF prefixes plus those two connected interfaces, those would be candidate to be redistributed from OSPF into RIP or from OSPF into EIGRP. So next, let's look at the redistribution between the OSPF and the RIP process. First step is that we go under the global routing process. So if we look at our configuration so far, we have OSPF process ID 1, EIGRP AS1, and then the global RIP process. So we'll say under the RIP process, I want to redistribute OSPF process number 1. Again, by default, there is no seed metric value. So I either need to specify this here with the metric, or I could specify the default metric. So if I said that the default metric was 5, this would apply to other non-OSPF protocols, because with OSPF I'm manually specifying the particular metric value that should be associated with that. So really, whichever way that you do the implementation, it's going to end up in the same result, that the routes should be installed in the RIP database, and they're going to get whatever seed metric you're either specifying on the particular protocol, or it's going to go back to the default metric value. Now, without looking at any other routers in the RIP topology, we should be able to tell, at least here locally on router 4, whether the redistribution was actually successful. And we can see this by looking at the show IP RIP database. We should now see, in addition to our local connected route, the 8 routes that we were learning from BB3, we also have a bunch of these prefixes that say they are redistributed. So if we look at this output again, show IP RIP database, and include just the keyword redistributed, we see that this is going to be the routes in the routing table as OSPF, in addition to any connected routes that are running the OSPF process. So when we compare the show IP route OSPF output, we can see the first prefix 155.28.7.0. This did make it into the RIP database, as did the 9.0, the 37.0, etc. Additionally, we see 155.28.146.0. This is not showing up as an OSPF route in the table because this is directly connected. So if we show IP route connected, this 146.0, this is being included, as is the 45.0, because these are the two connected interfaces that are running the OSPF process. Note that this is not going to include serial 0/0/0.1, because although this is a connected prefix, it's not running the OSPF process. So again, by default, when we redistribute OSPF into RIP, it's going to be whatever routes are in the routing table as OSPF, plus the connected links that are running the OSPF process. Now, if I wanted to include an additional route, let's say that I want to advertise my loopback interface into RIP, and I want to do this via connected redistribution, I could go under the RIP process and say redistribute connected, and I'll give these a metric value of 2. If we now look at the result in the RIP database, if we show IP RIP database and include the redistributed routes, we should now see that our loopback is included, but also the other connected links that were not running OSPF. So if we look at the show IP route connected and compare this to the show IP OSPF interface brief, the explicit redistribute connected command is including more than what the OSPF to RIP redistribution was. Now, ultimately, with whichever method that you choose is going to be dependent on whether or not you want to allow all routes to be redistributed, or whether you want to be very specific as to which particular prefixes will be advertised. Now, the case where this could become a problem is if I were to say that on router 4, I have this link that goes to VLAN 146, and then I have this link that goes to BB3. Okay, this is the 204.12.28.0/24 network. The link connected to BB3, this is running RIP. The link connected to VLAN 146, this is running OSPF. So again, when I redistribute from OSPF to RIP, it's going to be any routes that are actually learned from the OSPF process, plus the actual connected interface itself. Now, if I had other connected interfaces on router 6, let's say a loopback interface there. I have loopback 0, and this is the prefix 150.28.4.0/24. And I want to advertise this into the RIP process. Now, if I have other connected interfaces as well, I have this link that's going to the frame relay network. I have this point-to-point link that's going into router 5. If I simply say redistribute connected under the RIP process, it's basically going to match all of my connected links, which is then the VLAN 146, the loopback, the frame relay, and the point-to-point serial. Let's also assume in this case that I do not want to redistribute the link that's going to frame relay and the link that's going to router 5. So I want to advertise the loopback to BB3, but I don't want to advertise these other two serial interfaces. So this means we would need a separate redistribute connected statement, and we're going to match which of the particular prefixes that we do want to include. So on router 4, the way that we do this is with a route map. I'll say the route map is called connected to RIP, and by default this has a permit 10 sequence number. From here I could either call an access list or a prefix list, or I could match the connected interface directly. So I'll simply say match interface loopback 0. Now under the RIP process, I'm going to redistribute connected. I still need to set a seed metric, let's say metric 2. But now I'm going to filter this redistribution through the route map connected to RIP. When we look at the end result of this in the show IP RIP database, and we'll look at the redistributed routes, we see that the loopback interface was advertised, but the frame relay interface has now been filtered, and the point-to-point serial that is going to router 5. We can see this if we compare the RIP database output to the show IP route connected. So 155.28.0.0, that is not in the RIP database. nor is 155.28.45.0. The loopback is the 204 network. That's going to be in the RIP database because that's actually running the protocol. There's a network statement that's matching it. But now notice that the Ethernet that was running OSPF, this is now being excluded from the RIP redistribution. Now, this is not necessarily a bad thing. It just depends on what our end goal of the design is. If I want to advertise the loopback plus the VLAN 146 interface, then my current configuration is not going to accomplish that. What I'm actually doing here is allowing the loopback to be redistributed, not the connected VLAN 146, not either the connected serials, but then any dynamic information that is learned from OSPF. The reason why that these three connected links are being denied is that the route map on router 4 has an implicit deny after sequence number 10. So just like an access list or a prefix list, the route map is always going to end in an implicit deny. This now means that any interface besides loopback 0 will be denied from being redistributed into the RIP process. Even though when we look at the configuration under the RIP process, I have two redistribute statements, one that is going from OSPF to RIP and one from connected to RIP. Since I am explicitly listing the connected redistribution, this means it is then going to override the connected links that are running the OSPF process. Now, in reality, this is the design case that you would want as the default behavior, because it essentially gives us more control as to what particular routes are advertised into the routing database. So if I wanted to advertise the loopback but none of the other connected prefixes, this is how I'm going to do it with this config. However, if I want to advertise the loopback plus the interface that was in OSPF, it means that I would also have to permit that in the connected to RIP route map. So I could either do this under the same sequence number 10, if we show run section route map, or I could put an additional sequence after number 10 that's matching that additional interface, or matching an access list or a prefix list that is matching the address information for the link. So if we look at the show IP route connected, the prefix in question for that link is 155.28.146.0/24. If I then wanted to include this in the connected redistribution, I could say match interface fastEthernet0/1, call an access list that's matching it, or use a prefix list. So I'll say IP prefix list connected FA0/1 permit, and then the actual prefix plus the length. So 155.28.146.0/24. Now, as I mentioned, we could also use an access list to do this. However, the shortcoming of using the ACL is that we can match only on the address field and not on the subnet mask. Whereas the prefix list, as we talked about this before, for filtering with a distribute list in a RIP or a distribute list in EIGRP, this would be the preferred method of matching a route because it gives us the flexibility to match both the address field and the subnet mask at the same time. So now that I have the prefix matched, next step would be to reference it from the route map. So I have route map connected to RIP. I need a new sequence. We'll say permit 20. Then match IP address, prefix list, connected, FA0/1. Now the common mistake here to watch out for is that when you say match IP address, if I were to say match IP address connected underscore FA0/1, that would be calling an extended or standard named access list. So if I were to say match IP address connected FA0/1, this would be calling an ACL, not the prefix list. If I want to match the prefix list, I need to add that additional keyword prefix list in the match IP address prefix list and then the name. Now we should be able to see the end result of this if we now look at the show IP RIP database and again look at the redistributed routes. So show IP RIP database include redistributed. We can see now not only does it include the loopback, which is the 150.28.4.0, but now that VLAN 146, which is 155.28.146.0/24. So really in the end, it doesn't matter which way you do the implementation. It's only dependent on whether you want to allow all routes or just a subset of routes. If you want to allow everything, then you could just say redistribute connected or use whatever the interfaces that are running the dynamic protocols. So if I were to remove under the RIP process here, if we show run section router RIP, and we say no redistribute connected. So the only statement I have now is redistribute OSPF1 metric 1. If we look at the result of this in the RIP database, it does include, or it will include in a second here when it converges, it will include the VLAN 146. So that's our connected interface running OSPF. But notice that it doesn't include the loopback. Because when we look at the show IP OSPF interface brief, the loopback is not in the OSPF process. So it implies that it's not going to get included when we redistribute OSPF to RIP.